I'm going to work out some of the problems on the practice test. The first problems are just factoring. So we're not going to find a value of x that makes the equation true. Also, when we factor any common factor out, we're not going to be able to divide it out. So it's going to have to stay in the whole problem. So let's look at the first problem. And this is a difference of cubes. So 27 is a perfect cubed, x cubed is a perfect cubed, 8's a perfect cubed. So let's go ahead and figure out that formula. Remember that was a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. So for this particular problem, a would be the cube root of 27. That would be 3, and the cube root of x. And the b part would be 2. Now it's not a negative 2 because the formula already takes into account that it's subtracted. So let's plug those values in. So a minus b would be 3x minus 2. Then I have a squared. So I'm going to have to square the 3x. That would be 9x squared plus a times b. So 2 times 3x is 6x plus b squared. B is 2, so that would be plus 4, and that would be my answer. The next problem, let's see if we can factor anything out. And yes, I can factor a 3 out. I can't factor an x out because there's no x onto the 30 over here. So let's go ahead and factor a 3 out. That would give me x to the 4th plus 3x minus 10. Now then, 3x squared. Now then, let's see if I can factor the part in parentheses. And it's a 4th power and a 2nd power and a constant term. So I know that that's going to give me terms that have x squareds in them. And so I need two numbers that add to 3 and multiply to negative 10. That'd be x squared minus 5 and x squared plus 2. Now I have to see if I can factor the x squared terms anymore, and I cannot. Neither of those are a difference of squares, so that would be my final answer. The next problem, let's see if I can factor anything out. And I can't factor a number out, but I can factor that x out, so let's factor that out. And then I'm going to have left, I'm going to have x cubed plus 3x squared minus 4x minus 12. And since I have a cube, a squared, first power, and a constant, that could be a grouping problem. Let's see the ratio of 1 to 3. The 4 to the 12 would also be 1 to 3, so that will be able to be grouped. So we mentally split it down the middle. And what we're going to take out of the first part is an x squared. That would give me x plus 3. So the second part also has to have x plus 3. And notice that the sign is a minus 12 up here, but here it's a plus 3. So I'm going to have to get a minus out of there to switch the sign. So that means I'm going to factor out a 4, minus 4. So let's go ahead and write that. So x, now I would have x squared, can't see the squared, times x squared minus 4 times x plus 3. X squared minus 4 is a difference of squares, so let's factor that. X minus 2, x plus 2 times x plus 3, and that would be my factorization. Okay, the next part, now we have to find the solution. So we have to find the values of x that make it true, and we have to find all the solutions, so even any imaginary solutions would have to be included. So let's go ahead on the first one. I can factor out a 2, because a 2 is in each of the numbers, and also an x, so let's factor out a 2x. And that would give me x squared minus 2x cubed minus 25x plus 50. Now that's okay, so I got my exponents right. Now that's going to be a grouping problem, so we'll split it down the middle. And I can factor an x squared out, and that would give me with x minus 2. So on the other side, I have to have x minus 2. Of course, that's equal to 0. So the plus becomes a minus, so I'm going to have to factor a minus out, and I would be a negative 25. So let's write what I have. I have 2x times x squared minus 25 times x minus 2 equal to 0. I need to factor the x squared minus 25. That's a difference of squares. So I have 2x, x minus 5, x plus 5. Now my x minus 2 equals 0. So the value of this first x that would make everything go to 0 is 0. So x is equal to 0. Then I have x equal to 5, x equal to a negative 5, x equal to 2. Okay, let's move to the next one. And that's a sum of cubes. So let's review that formula real quick. So what that would be is if I have a cubed plus b cubed, that would be equal to a plus b times a squared minus ab plus b squared. So for this particular problem, the a is equal to x and b would be equal to 4. So let's plug those in. So what I'm going to have is x plus 4 times a squared minus ab plus b squared. That'd be 4 squared. Okay, so for the x plus 4, that's going to give me one of my zeros as x equal to a negative 4. The part that is the squared for a sum or difference of cubes will always be imaginary, so we'll need to use the quadratic formula. So for this particular one, I have the a would be equal to 1, the b is equal to a negative 4, and the c is equal to a negative 16. So let's go ahead and set up the quadratic formula. So I have x is equal to a minus b plus or minus the square root of b squared minus 4ac all over 2a. That would be minus b. So b is already a negative 4, so minus a negative 4 plus or minus the square root of b squared minus 4 times the a value times the c value, so negative 16, all over 2 times a. So that's going to be equal to 4 plus or minus the square root of a negative 4 squared. That's going to be 16. And then minus, and notice this is a negative 16, so a minus and a subtract would make that a plus. And I have 16 then times 4 would be 64 all over 2. Okay, so anyway, that's going to be 4 plus or minus the square root of 80 all over 2. Now let's change that 80 to the square root of 16 times 5 all over 2, and then the 16 will come out as a 4. 4 plus or minus 4 times the square root of 5 all over 2. So I've got 4 over 2 plus or minus 4 times the square root of 5 over 2, and that's going to be 2 plus or minus 2 times the square root of 5. So those are my two solutions. There's one, and there are two of them. Okay, let's go down to another problem. And let's see what I can factor out at the start. Looks like I can get a 7 out of there, and I can also get an x squared out of there, so 7x squared. And I would have x squared minus 3 equal to 0. I've got to find all the solutions, so the value of this x squared at the front would be x equal to 0. That would be one of my solutions. And to figure out what would make the part in parentheses go to 0, let's just set up a little equation. So x squared would be equal to 3. Taking the square root of both sides, I get plus or minus the square root of 3. And that would be my other answer because there's no more simplification I could be done. The next one is, we got that 18 over there. That has to go to the other side. So let's go x to the fourth plus 3x squared minus 18 equal to 0. And this is a quadratic form. You can see that I have a fourth power, a second power, and a constant term. So that's going to factor just like any of the basic factoring, except I'll have x squared terms. So let's go ahead and set that up. And I need two numbers that add to 3 and multiply to a negative 18. So that's going to be plus 6 and a minus 3. Let's check to see if I can factor those. And neither one of those terms are a difference of squares. So I'm going to have to come up with the values of x a different way. So I'm going to set up a little equation. X squared plus 6 equal to 0. X squared is equal to a negative 6. Now I'm going to take the square root of both sides. X is equal to plus or minus a minus the square root of 6. Now, I can't simplify the 6, but the negative comes out as an I. So x is equal to I. I need to put the plus or minus there. Plus or minus I times the square root of 6. And for the other one, I have x squared is equal to, oh, I'm getting ahead of myself. X squared minus 3 equal to 0. Now x squared is equal to 3. Take the square root of both sides. X is equal to plus or minus the square root of 3. That can't be simplified any further, so that's my answer. Okay, the next problems are going to use a graphing calculator, so I have this emulator, and I hope I can get it to work on my computer here. So the first thing I did is I went to y equals. I'm going to enter my equation, and notice that plot 1, plot 2, plot 3 are off. They need to be off. So I'm going to enter in x to the fifth minus 3x cubed plus 5x squared, minus 2. Okay, let's take a look at that graph. Okay, so what we need to do is we are going to graph the polynomial. I'm going to wait till I get my zeros and my minimum and maximums to do that. So zeros, that's number 2 up here. I'm going to go ahead and get my zeros. So I'm going to go second trace, 2 for 0. I'm going to move the cursor It's not the most responsive, but there it goes, finally. Okay, so I've got the cursor to the left of the 0. I'm going to press enter. Now it's going to go to right bound. I'm going to move my cursor to the right of the 0. See the way it moved slightly to the right of the 0. Press enter. Press enter again. And it should give me my 0. And it says my 0 is a negative 2.2. For the x, and the y is, it says 1e to the negative 12. So that's 1e times 10 to the negative 12. That's a 1 with 11 zeros in front of it, so that is a 0. That's basically 0. So I've got that. Let's go ahead and get another 0. Let's move the cursor. Up, second trace, 0. And let's move the cursor. Okay, it says to the left bound. It is still to the left of the 0. I'm going to press enter. Got to move it to the right of the 0. There the cursor drop below the line, and it's to the right of the 0. And it gives me a negative 0.6. Y is 0. And I have one more 0 to get. So second trace, 0. And let's move the cursor to where it's to the left of that other 0. Okay, it's still to the left. Press enter. Now it's to the right. Press enter. Press enter. And it says that it's at 0.8. Zero. So those are my zeros. Okay, for now I need to get the maximums and the minimums. So I'm going to go second, trace, and I'm going to get the minimum. And it's going to say go to the left of the minimum. Okay, so the minimum is that lowest point right there. So let's go to the left of it. Come to the left. Now it says right bounds. That means I go to the right of it. Enter. Enter. Okay, and it says that my minimum is a negative 1.3. So I think that's probably 4, so I'll go ahead and just write them in. We got the minimum was a negative 1.3, negative 2. Let's go get the maximum. Now I'm not going to change the scale of this, so it may not give me, because I'm not sure that it that this emulator wouldn't get hung up. So anyways, you second trace, and I'm going to get the maximum. And the maximum is that point that I can't see. I'm heading up toward it now. So I'm just going to wait till my cursor comes back down on the left. There it is. So I'm to the left of the max. I'm going to press enter. Now I'm going to go to the right. Okay, so I can see I'm to the right. Press enter. And it gives me the maximum is a negative 1.7. 13. Okay, so we can go ahead and plot this. So I've got a 0 at a negative 2.2. So negative 1, 2, negative 2.2. I've got a 0 at a negative 0.6. I've got a 0 at 0.8. I've got a minimum at a negative 1.3, negative 2. So negative 1.3, negative 2. And I've got a maximum at negative 1.713. That's going to fall off my graph, but let's just put it up here. So this is going to look something like this. I missed my point. Let's erase that. See, something's not right here. So let me stop this for a second and see what I did wrong. Okay, I don't know what I did wrong when I got the minimum before, but it isn't right. So I just redid the minimum. And this is the value that I have over there. So the minimum, the x value was 6.69 times 10 to the negative 7th. That's virtually 0. So I'm going to put the x value as 0, and the y value is a negative 2. So let's erase some of those points. And so we have the maximum is a negative 1.713. Remember that was way up here. And then I have my minimum at 0, negative 2. So now my graph should look like this. Okay, the maximum number of turning points would be equal to the degree minus 2. This is a fifth degree. Degree minus 1. So the maximum number of turning points is 4. And let's see what else we need to find. Graph the polynomial, I did that, found the zeros, state the maximum number of turns, state the local minimum and maximums, and I have those listed too. So I'm done there. And since that took a while, I'm going to skip 22 and move on to the next problem so the video is not so long. Okay, for the next part, what we have to do, we state the zeros if the degree is even or odd. Now, it's not asking if the function is even or odd. It's asking if the degree is even or odd. That's the exponent on the highest exponent on the x, and to describe the end behavior. Okay, so for the zeros, for the first one, what we're going to have is to make this go to 0, this x would have to be equal to 0. So one of my zeros would be x equal to 0. For x minus 4, that would be x equal to 4. And for x plus 1, it would be x is equal to a negative 1. So there are my zeros. The next thing I have to do is state if it's even or odd. Okay, so I have an x. That's going to multiply by x minus 4, so I'm going to give me an x squared. So when I multiply this, that will be x squared. And then when I finally take that and multiply it by this part, I'm going to end up with an x cubed. So the degree is 3. So that's odd. And the last thing I have to do is describe the end behavior. Okay, since the degree is odd, these are going to start and end in opposite directions. So it's either going to look like this or like this. Since the coefficient is a plus, it's going to go like this one here. So let's describe the end behavior. F of x does what as x goes toward a minus infinity, and f of x does what as x goes toward a positive infinity. And what we can see is it starts low, so it's coming from a negative infinity, and as x goes out to the right, it goes toward infinity. Okay, the next one, state the zeros. Okay, zeros. And for the x cubed part, I'm going to have x equal to 0. For this part over here, I have x equal to 5. So x equal to 0, x equal to 5. Is it even or odd? Well, I'm going to have this cubic times this x. That's going to give me an x to the 4th. So that's an even. So an even degree, it's going to either look like this. They're both going to go the same way. And so the leading coefficient here is a negative, so that's going to mean it's going to look like this one. So we're going to say f of x does what as x goes toward a negative infinity out to the left. F of x does what I'm not filling those in yet, as x goes toward a positive infinity. And what we can see is it starts low, ends low. This would be a negative infinity, negative infinity. Okay, let's do the next one. So my zeros, what I have is for that 3 doesn't have any effect. Here I have x equal to 1.3. x equal to negative 4. And I have two zeros here. Both of them are at x equal to 3. So I'm going to write that. X is equal to 1.3. X is equal to negative 4. X is equal to 3. Those are my zeros. Is the degree even or odd? Okay, so here's my first x. It multiplies by this. I get an x squared. Now this will multiply by this term over here, but this term is a squared. So this is going to be a squared, and I have a squared multiplying by that, so my end is going to be an x to the 4th. Okay, so it's x to the 4th. That would be even. And so here let's write f of x does what? As x goes toward a negative infinity. And f of x does what? As x goes toward a positive infinity. And what we can see is I have an even degree, and the coefficient in front of it is going to be positive, so it's going to start high and end high, look something like a W. So these will both be infinities. Okay, for the next one, I don't know what the zeros are. I don't know if she miswrote that. I'm not going to enter that in the calculator. I can't factor that. So for the zeros part, I'm going to leave that go. Is the degree even or odd? Well, it's odd. So the degree is 5. That's an odd degree. And we can see that the leading coefficient is 2. So it's going to start and end in opposite directions, and when it's odd, that starts, ends opposite directions, positive leading coefficient, so it's going to start low and end high. So we're going to say f of x does what? As x goes toward a negative infinity. F of x does what? As x goes toward a positive infinity, and what we had already determined is it's going to start low out to the left at a negative. As x goes this way, it's dropping, and as x goes to the right, it goes up. Okay, so let's go ahead and go to the next one. And what we have to do is we have a lot of stuff we need to do. We need to say where the value of the function, that's y. Where is y increasing or decreasing? Where is y greater than 0? Where is y less than 0? If it's an even or odd function, and describe the end behavior and approximate the zeros. So I'm going to go ahead and approximate the zeros first. Actually, she's got that on there, so I guess we really don't have to worry too much about that. So the zeros are, and actually I'm doing part F, so let me write that on there. Zeros, I've got a negative 0.40 and 2.40. And let's go ahead and find the values for where f is increasing or decreasing. So from this point, the function is increasing. From that same point on the other side, it's going down. We're going down a hill. Okay, so that's decreasing, and this side was increasing. Okay, so right here is where it changes. And then we can see that the x value of that point, so we're stating the x values where y changes from going down to going up. And that occurs at this value of x equal to 1. So what we can see is that this function is decreasing. For when x is to the left of 1. Everything out here, it's dropping, and that's x is less than 1. Okay, that's the only place it's decreasing. Then it also says where is it increasing, and that's the green arrow. So once I get to the right of x equal to 1, that's all in here, it's increasing, and those are the values where x is greater than 1. Okay, now I've got to describe the values for where f of x is greater than 0. So what that wants me to do is I'm going to I'm going to state the x values, what makes y greater than 0. So y is greater than 0 on these parts. Here's where y is greater than 0. And here's where y is greater than 0. So what are the x values corresponding to that? Well, for the green line on the left, so that was for B. That's where y is greater than 0. And what we're going to say is are those values where x is to the left of a negative 0.4. So x is less than a negative 0.4. And x on the other side would be greater than 2.4. Okay, let's find out where it's less than 0. The place where the y drops below 0 is down here. And those x values, that's part C, y less than 0, and those values of x is between a negative 0.4 and x is between 2.4. Okay, what else do we have? Do we have to say whether it's odd or even? Well, if the function is even, if I have a point on, it's got to be a mirror over the x-axis. So, for example, this point right here would have to be mirrored on the other side of the x-axis, and it's not. Also, if it's an odd function, it's got to be symmetrical with respect to the origin. So this point on one side, like say this point right here, would have to have a corresponding point on the other side up here, and it doesn't have that either, so this is neither. So let's see, that was D, it's neither. And the last part says to describe the end behavior, or we could see that it's going from infinity to infinity as the y changes. So let's go ahead and write that. And I'm obviously didn't see the blanks. The screen wasn't big enough, so I'm going to write f of x goes to infinity as the x goes very negative. And then f of x goes toward up again as x goes very positive. Okay, let's take a look at the other one. I'm going to shrink this down so maybe I can use Okay, so what I have is you can see that I have a 0 here and a 0 at 1.3. So the part that says approximate the zeros, that's f. I'm going to go ahead and write that in there. So the zeros are a negative 1.30 and 1.30. Let's go ahead and do the end behavior since we can see that as x goes out to the left, the y values are increasing. As x goes out to the right, the y values are increasing also. So that's going to be another infinity, infinity. That would be E, I think. Okay, so I'm going to say f of x, the y value goes to positive infinity up as x goes very negative to the left, and the y value goes up toward a positive infinity as the x gets very positive to the right. Okay, is it odd or even? Well, let's take a look. What we have is if it was an odd function, for every point that is below the x-axis. It would be symmetrical with respect to the point 0, 0. So say this point right here would have to have a corresponding point right there. And it does not. So it's definitely not odd. It's not symmetrical with the origin. Let's see if it's even. That means for every point on one side of the x-axis, it has a corresponding point on the other. And you can see that that's true. If I flipped it over the x-axis or cut it in half, it would be an exact mirror image. So this is an even function. Okay, let's see what C says. C says describe the values for which x is less than 0. So we're looking for the values where x is less than 0, and that's going to be where y is less than 0. So what x values give me that? Well, here's where y is less than 0. So you can see that's right at these x values right here. So y is less than 0 for everything that's in here. That would correspond to x values right there. So what we would have is we have a negative 1.3 to a positive 1.3. So x has to be in between those. And where x is greater than 0. Okay, well, that's the other side. So let's figure out that. Here's where y goes positive in there. So the values of x that give me this positive y on the left are all these x values out here. Where y goes positive on the right-hand side are all those values. So I can write that as where x is less than a negative 1.3 or x is greater than 1.3. And the last piece of this is to say where is x increasing and where is y increasing and decreasing. So let's find those. So here is where y is decreasing. Okay, and we're walking along from left to right, and we're walking downward all the way there. Then we go back up, then we go back down again right in there. So I need to capture those x values. So what I have is we're decreasing, going down, when x is to the left of this point right here, a negative 0.9. And when x is between 0, right here's a value, that's x equal to 0, and x right here is a positive 9. And where x is between 0 and 0.9. That's where I'm decreasing. Okay, now where am I increasing? Okay, so let's do that. So I'm increasing, walking up a hill here, go downward, then I'm walking up a hill here. So the x values are between these two x values, and then x going on up. So what we have is where x is between a negative 1.3 and 0, that corresponds to this green part in here, and then when x is greater than a negative, where x is greater than 8.6. Last problem. Says if the parent is this, what happens? Well, this can't be right. That's got to be a fifth power. Okay, so anyway, what we have is we have that we're going to see this -3 force. That's going to be a shrink in the y direction. So that'd be vertical, shrink vertical by a factor of 3/4. Because it's negative, it's going to reflect across the x-axis. This -1 is going to be a shift down of 1. And h here would be equal to a -3. So it's going to be shift left. Three units. That's it.